Hi, good morning, everyone. I want to say thank you all for being out here for my presentation. My presentation today is just to give you all a feel of challenges we face processing petrophysical big data. This work was done by myself and Emenike Jimuda. So a little bit about myself. My name is CJ Jimuda, like Suzanne introduced earlier. I'm a full stack data scientist and principal at hybriData Solutions. And we're a small startup out of California, Los Angeles, California. So our key expertise is in mining value, leveraging artificial intelligence, industrial Internet of Things, and big data technologies. Prior to getting into artificial intelligence, industrial Internet of Things, and big data, my desire for mining value from data actually started up from the oil and gas industry. So I started off as a reservoir engineer and also worked as a production engineer. I worked with ExxonMobil and Era Energy as well. As far as my presentation for today, first of all, I'll give you guys a feel of why we started up processing petrophysical big data, and also what big data processing challenges are you bound to face when processing one. Then next on, I'm going to dive into like the Etl workflow we use in processing the big data, and also how we're able to implement an ETL automation. Then finally round up with conclusions and some references I have. So the actual workflow that led to the challenges we face was re-evaluating old well logs for opportunities. But again, what I did was enumerating beyond that what other processes you could derive more value from in processing petrophysical big data. Some of them could be like you're trying to drill a new well, performing like pre-drill analysis of the offset wells, or even after you've completed the well, your post-drill analysis. So for this process, it was more for like batch data. So if it's like well drilling, that has to be dealing with streaming data, processing the data as it comes on the stream. Also, another areas too you could derive value from processing petrophysical big data is when you're unable to assess effectively, be it like your well or your field reserves. The great thing about it is, since it's big data, if it normally takes your team, say, sometimes it could be like 3 months or 1 month, or depending on how knowledgeable you know about the field. But with processing petrophysical big data, you can quickly arrive to, what are your high sides, your low sides, or your most likely cases. Some other areas too in processing petrophysical big data, if you have like challenges like inferring like certain geological features or properties. So moving on to what big data processing challenges. So typically, if you have like, let's say 1 to 10 well log files, the log files were actually like raw well log files. What you could do could just be, because the big data we processed was, it was stored, it had a link to it. So for something like that typical scenario, if it was like 10 wells, you can just simply copy the link on a browser, quickly download it. And that's for that kind of process, you don't really need any big data infrastructure for that. However, the big data processing challenges we face was now when you have almost like 1,000 well log files. So the chart you can see below just gives you a sense of feel. The well name with the blue marker tells you like the well has a link to it. So all these wells are all these were all enumerated on Excel files. So first of all, you have to go dig down to your cells of interest, copy out the different URL links, and download the data. So for the challenges we faced, this were like the ETL workflows we performed for analyzing that petrophysical data. First of all was downloading each well log files individually from the web, like I alluded to earlier. Read the log data from each of the files, enrich the metadata and the actual data files, and save it as an Apache Arrow data format before loading it to whatever data warehouse you wanted to load it to, since it's a batch process. Then at the end of the day, the goal of doing all the steps is not just only, some ETL workflows could just be simply saving it to, like I alluded earlier, to a data warehouse where someone else, an analyst, can go in there and dig deeper. But for this case was feeding it into a model to assess possible opportunities from all well logs. So now, since I enumerated the ETL workflow, so I'll now delve into each and every of the bullet points I highlighted there to give you a feel of, delve deeper to each and every step we performed. So you saw the Excel file that I shared earlier. So each and every one of the Excel files, you have to go in there, get the links for each of them, append your extracted links to like a list, account for different types of errors, then eventually save the file. I have like a kind of like a snippet of the code, like the Python script code we wrote for being able to dig into the Excel file, go into the sheets of interest, appending the links of each of the URL. So on the left is just the Python script, which we all can take a look at later on. So like I showed earlier, we want to download each well log file individually from the web. But first of all, we have to get the links out of the Excel files. Some of the challenges I forgot to mention was being able to find a Python API that could effectively, not just only one, like you had to like download like a couple of different APIs to be able to dig into an Excel file to extract each and every one of those links. But that's like one of the challenges in terms of that, getting out the URLs for each of them. So now moving further to downloading of the log file. So after we've extracted all the links, we want to go in, download each and every one of the well log files. Challenges with that is, one is since the data was on the web, you have to account in your code base, you have to account for connection errors, different kind of errors. If someone has done something like web scraping, like scraping the web, these are typical type of workflows you have to go through to download any particular data or any object on the internet you want to download. So moving on to the next bullet point I highlighted earlier. So reading the log data from each file. So for reading the log data from each file, we had to extract the actual data and the metadata, the header data, and as well, since we plan to pipeline, we plan to build like a data processing pipeline at the end. So we also have to account for errors, and then so just give us a feel of the code snippet for reading each of the well log files. We used a very popular API, which I think some of the presenters yesterday talked about, LASIO API, very great, very effective. Although like so some for some certain scenarios, if you want to get out like customize attributes, the presenter yesterday from Data Verdict, she took something about. I mean, she actually went to the nitty gritties of what makes up the LASIO file. So depending on the variables, the features you want to get out of each well log file, you can actually go deep down. Beyond that, you could use like regular expressions to capture any particular fields or features you're most interested in. And I forgot to mention too, as you can see over there, we also use like the Pandas API to perform this job as well. So now getting to like enriching the metadata and the actual data files and saving the data as an Apache Arrow format, Apache Arrow data format before loading it to AWS S3 data, bucket. One, we put Apache Arrow there because so when you're processing the well log data, you're always going to have to read and write and read the data, query the data. So what the Apache Arrow format data does for you, if you look at the chart on the right, so currently I think most people now implement their, most people I like to think implement their workflows with Apache Arrow format data. Because of it prevents you from any form of like communication costs. So communication costs, you can see on the left, it says copy. You have to always copy and convert the data. Apache Spark was originally written in Scala. So if you want to work with Python in PySpark, that challenge of deserializing the data and serializing it, the network costs for a big data workflow, it will be more expensive. So, and that's why we, went with saving the data as an Apache Arrow format data. This is just a snapshot, giving us a sense of feel of after we had, written all the scripts earlier, how we uploaded it into an S3 bucket, and also how we wrote it as an Apache Arrow format data. So the next step in the ETL automation is, at the end of the day, is, making the data ready for, let's say, our Apache Spark ML pipeline, machine learning pipeline, Keras deep learning pipeline. So beyond just saving it now, you now delve into typical workflows of based on what your domain expertise feels like that are the most significant features that affect what variables whoever the client is interested in. So we dropped almost like 152 columns to about 13 columns. We did so many other things like dropping duplicate columns, accounting for null values or NA values, and also missing values. At the end of the day, moving into querying, because this was done for like 5 different fields, we applied the split, apply, combine transformation technique. We also use the Pandas UDF, almost is like a decorator, where if you're doing certain like group operations, for you to be able to take advantage of the Apache Arrow data format, you need to use, Pandas. So some other things, challenges we had was reading the data frequently. So by catching the data frame, you can, most especially if it's after you've done the group operations, after you've done the because the group operations is very expensive, computationally intensive operations. So you want to catch the data frames, and that way you're, in terms of like your network cost and operation time, it's lesser. So after doing that, potential next steps. So for the tags we did, we didn't have to put it like in an actual production pipeline. But the great thing about this is, so what I'm talking about now is the Apache Airflow data pipelining process. If some of you came around yesterday, you must have heard about this. But what this does for you, makes it easy for you to reproduce your data pipeline, individual workflows. The funny thing is that you saw a script we wrote. So one great thing too about the Apache Airflow is that it goes with the methodology of you defining what they call like a DAG, a directed acyclic graphs. For Apache Airflow, it's just like you're defining different tags. So for instance, first of all, for like I talked about, like downloading the files, reading the files, saving the files, you can actually use either one of their base classes, the dummy, what they call it operators. It could be a Python operator or a sensor operator. And the great thing too is for this workflow, the part we put about saving the data, uploading the data to the S3 bucket. Apache Airflow has like APIs that you can just indicate the keys and the values of your S3 bucket in that way. It will alleviate you even having to write the script we wrote earlier. So for conclusion, at the end of the day, because this process was actually done after the old well logs, I mean, after they've, been completed. But if you, to get the most value out of your petrophysical data, you want to start from the get-going while you're getting the data or while you're drilling. First of all, like if you're getting your WITS ML data, although for this case now, for this scenario, you're not going to be making use of an Apache Airflow pipeline techniques. You want to think about other platforms like using the Apache Kafka. Currently, the Apache Kafka, you can use it to handle what the Apache Storm does for you. But yeah, you can use a host of all these other different Apache open source technologies to process real-time data, and by you processing real-time data, you get a lot more value from it on the spot, and make whatever corrections you want to make to be it your logging program or be it your drill well programs or your drill well plans. These are few references from me. There's still like a whole lot of references. You feel free to look at it. And that's all from me. Thank you. Any questions too?
Could you share some use case of the people who are using the log data as running some like say machine learning or deep learning? What are their applications, or more specifically, what are their applications?
So if you look at my first slide that I started up, I talked about, so the use case of this was just re-evaluating old well logs. The first one was just what we used it for, just re-evaluating old well logs. But again, like I alluded, you can also use it for, be your pre-drill analysis of offset wells. And I also said post-drill too as well. And other, like the other two. But for this particular workflow, we're just re-evaluating old well logs for opportunities. What?
You did it.
Yeah.
How did you store your data frames?
I stored it in S3 bucket. Like I showed, just, yeah, 1 second, I'll try to get it. So you can see right here, you can see like me using pandas there, mapping each and the functions that I showed earlier too, each of the log files, yeah. Using AWS Boto tree, just like an AWS API. But,
Is your workflow public?
huh?
Is your workflow public if you're trying to establish a good workflow? Why not share it? Try to make it public and let get input.
I mean, like, right now, I don't understand, I think I don't understand your question.
Oh, well,
Yeah,
in a public domain, if
yeah.
you're trying to establish a public standard on how to,
Okay. Well, the truth is, so so if you saw the slide I shared at the end here, right? So if you're using like an Apache Airflow for this type of workflow, I wouldn't need to write this script here because they have, the API already. So I would say, yeah,
it doesn't apply directly to well object.
it doesn't, but I mean, in the part of me eventually storing it to an X3 bucket, that's where I would want to use it. Maybe I didn't get you completely, but we can talk about that after. I'm not hearing you so clearly, but I can come closer. Yeah. Yeah. Mm-hmm. 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 Yeah. I have. Okay. First of all, great question, by the way. First of all, I want to just tackle one question. So first of all, we weren't storing it to a proprietary data format. It's an open source, like, I mean, anyone can store it into an S3 bucket, right? Then secondly, to your question, I think you're mixing, so like this was like a batch flow, right? Data processing. And this data was not stored in the WIS-ML data format, right? So my last slide was the best approach would be about, I mean, from once the data is streaming out of your WIS-ML server or whatever WIS-ML client, right? You want to immediately do whatever processing you want to do on the data. So that's kind of like, what I was, pointing out. But this was not for, I mean, a WIS-ML data. It was more like an LAS file, already stored for a long time. Thanks. Oh, sure.
In this process, were you dealing with the aliasing problem at all? Or you're just reading the data into the S3 buckets to do the process later?
What do you mean by the aliasing problem?
Mnemonics aliasing.
I didn't have that challenge. I didn't, yeah. But it wasn't just only storing it into the S3 bucket. If you saw the slides I put up earlier, so the storing into the S3 bucket is just one of the, steps. But other parts of, reading the well log file, downloading the well log file, getting the URLs, all those are like, the different challenges. But once you're able to overcome those challenges, you can be able to, like, for our case was processing like 1,000 well log files. So once you're able to, go through the hurdle of writing the script, I mean, you already have the script set up that you can, yeah, use it for 5,000 well logs. As long as you write your code in a way that could be efficient. Yeah.
More than that, like a million LAS files?
I haven't, but it can do that. But as long as maybe you have like a cluster and a couple of nodes spin up, yeah, to do that.
Have you considered to add spatial data to that?
Huh?
Have you considered adding spatial data?
We didn't consider that, but I mean, if the client wants us to do that, I think it's going to add more. I mean, yeah, I mean, we could recommend that, yeah, but yeah.
So, this presentation will be made available.
Yep.